Hi everyone, I'm Shrutirupa Banerjee and this is Introduction to Blockchain Part 2. The first video was about what blockchain is and we tried to understand blockchain in layman's terms. This time we'll get into a bit more technical and let's get started then. I'll just share the screen. So how does a blockchain work? This is what we'll be talking about. But before that, we'll understand about some terminologies that we need to understand, uh, which are important for understanding how ultimately blockchain is working. Also, I would like to make it clear that we'll be talking about blockchain with reference to Bitcoin because Bitcoin was the very first cryptocurrency that came into picture, the first white paper, and because of it also we came to know about blockchain. So it's better that we start understanding about it from the base, and let us know if you want us to cover some more topics, some other platforms and other functionalities like how blockchain works in other platform also. They are kind of similar with little bit of differences. So just let us know. We might cover that also. So let's get started. Let's have a recap. So blockchain is decentralized. Decentralized in the sense that there is no central authority. Distributed ledger. So we have transactions that keep on happening. So the transactions are kept as record or any other data that you're dealing with the blockchain, and they are kept as records and it is available to everyone within the network. I mean, whichever peer or node is over the network, they all are having that. Immutable, as I always say, once in a blockchain, always in the blockchain. So whatever information that is getting uh, updated in the blockchain will always remain in blockchain. Transparent, because whatever transaction is happening, it is again visible to everyone within the network. Now it depends upon the kind of blockchain you're using, public, private, and that is completely a different story. Anonymous, so apart from your public address, nothing, no other information will be over there. I mean, the transaction that has been made, that's it. So who are you, where do you belong to, those kind of informations will not be uh, visible to anyone within the network or anyone outside the network or anywhere, uh, if we are talking about public blockchain over here. So in that way it is anonymous. Some points that we need to remember so that it becomes easier for us to understand the other terminologies are that blockchain is nothing but a linked list that contains data and the hash pointer, and that pointer is pointing to its previous block, hence creating a chain. And how is it connected to its previous block? Through hashes. That's why the name hash pointer. The blockchain is maintained by peer-to-peer network, of course. The network is nothing but they are the collection of nodes and they're interconnected to one another. And what are those nodes? These are the machines that you're using for making a transaction. Cool. You remember the structure of the blockchain, right? So you can see that this block is connected to its previous block. This block is again connected to its previous block. And it keeps going back to the very first block ever created. And the very first block ever created is called the Genesis block. We did discuss about it in our previous video. So here we'll be talking about Merkle root. See, hash of the previous block is over here. Nonce is something that we require while during the process of mining. Difficulty target is again that we require during the process of mining. Version, the current version, you don't have to deal with it currently. State, see, since we are talking with reference to Bitcoin right now, in using Bitcoin, what we are doing, we are making transactions. So what is the current state of your account? I guess that gets updated over here. So the balance of your account, the code that might have been used, maybe in terms of smart contracts, we'll talk about that later. Storage that is being used, that is linked with it, and the list of transactions that we have. So there are lots and lots of transactions, right, that are happening and they are getting updated in the block, within the blockchain, right? So it is related to all of them. and we'll get to know about them one by one. We'll start understanding them in details. These are the main four terminologies that we'll talk about. The main things right now are hashes, Merkle root tree, and consensus mechanism. I'll give you a bit detail about what Byzantine fault tolerance is as well. Hashes. Now we know in cryptography, we have been introduced to the concept of CIA triad: confidentiality, integrity, and availability. So here we are talking about the integrity part. Hashes are used to maintain the integrity of the blockchain. What do you mean by maintaining integrity? Is that if you have a data and if you're sending that data to someone, so creating a hash of the data makes you aware of the fact that whether there has been any kind of modification to that data. So you'll understand. How you'll understand? Wait, I'll give you an example. So this is using SHA-256 algorithm over here. Okay, and I'll just select ABCD. You'll see the SHA-256 hash over here. If you just add E, you see the entire hash is changing. So if the data that I am sending you a secret is your information, is your message over here. So this is the hash of it. And if I just add a full stop, you'll see the hash changes. So this is how you're maintaining the integrity. You're able to understand if there is some kind of change that has happened to your data. So that is why we say that the integrity of the blocks within the blockchain is maintained, because we are using hashes. Now, hashes are one-way functions. What do you mean by one-way function? I'll give you an example. Like you must have heard about, you should be knowing in fact about encryption and decryption. So if there is a data, you encrypt it, you have a ciphertext. Then when you decrypt it, you get the plain data. So there are two functions. It is a two-way function. You are able to reverse the data that you are generating out of the first function. Again, this way. So suppose fx is a function. Sorry. Reverse of y is not equal to x, then it is a one-way function. But in encryption and decryption, what is happening? That the reverse of y is leading us to x. That is why we are able to encrypt and decrypt it. But in terms of hashes, we cannot do it. It is just a one-way function. So you just have the value of x. You use whichever function that you use for creating the hash, and this is the hash. You cannot just reverse the hash or undo a hash to find x. You cannot do it. You will have to put randomly different values of x over here to see which of them matches. Now, since each and every hash, each and every data is giving you a unique hash, it means that no two different values of x should give you a similar y. That is why you need to use a stronger hashing algorithm, because if that is happening, then it is not a secure way of doing it. We'll talk about that maybe some other time. We don't have to get into that details right now. So these are hashes. These are one-way functions. I hope you understood. The first hash that was calculated was for the Genesis block. And why was it calculated? It was calculated for all the transactions that happened to that block. Now what happens when the next block, since Genesis is the very first block, the next block that was created, and that block was using the hash of the previous block, that the Genesis block, the first block that was created, and all the transactions that are present in that current block, they link together to form another hash, and that is how each and every hash is linked to each other. Hence, a chain of blocks is formed and is called blockchain. So after hashes, let's understand what Merkle tree is. Merkle root. Now, Merkle root is the hash of all the hashes, and that too of all the transactions that are part of the block in a blockchain. Now, it is important for us because it is actually helping us for verifying and validating whether the transactions are all okay and there has been no modification or change. So one thing that I'd like to make it clear is already mentioned over here is that these hashes are not stored in a sequential order, but rather in the form of a tree-like structure. If you know about binary tree, you can totally understand this. So these are your 4 transactions. The hash of these transactions are over here, then they are combined together to form this. They are combined together to form this, and these 2 are combined together to form this. So this is the this is the grandparent or parent hash, whatever you want to call it. They're the child, grandchild, or whatever you call it. So this is how they are linked, and these all are present over here. Merkle root. So a block is having all kind of information if you would take care of it. If you notice everything what is happening over here. So Merkle tree, any other information is that every transaction occurring on the blockchain, yeah, we know about it. Yeah, it's just a simple mathematical way to verify that the data on the Merkle tree are all good, are all validated, are all verified. Next is Byzantine fault tolerance. I will not get into much of detail about it, but this is one kind of problem that we used to have. And to solve this problem, we came up with a solution which is called consensus mechanism. So it is just a characteristic which defines a system that tolerates class of failures that belong to Byzantine generals problem. Now, the problem was such that if there are 2 generals over there and they are at 2 different places, they are remotely connected to each other, and they have to just just perform a war against their enemy. And now both of them are at a remote position, and now they use a single person for conveying some messages to one another. Now the problem arises over here is, what if the person who is conveying the message is malicious? So they would just perform the war at different times, or one may perform and another may not. So this is a kind of problem. This is the fault that we were talking about. So this is the problem that we are trying to solve. What if this happens? So it is just the main aim to think about Byzantine fault tolerance is to create a secure consensus protocol. Why consensus protocol? Because you are working on a virtual network. Within the virtual network, there are lots and lots of transactions that are happening. How do you verify if the transaction that has happened is all valid? There might be a situation, because ultimately whatever is happening is nothing, just a piece of code. There might be flaw in that piece of code. It is possible, right? Nothing is 100% secure. So there might be a slight chance that there is some flaw in the code, or it's possible for you to manipulate the entire network in such a way that you can perform double spending. Double spending is in the sense that suppose you have just 1 Bitcoin in your account, and you send 1 Bitcoin, that 1 Bitcoin to somebody, and then meanwhile you again send 1 Bitcoin to somebody else, and you're able to send 2, something similar to that. Will not get into that detail. I just give you a gist of what it may happen, what may happen in that situation. So we are trying to solve those kinds of problems, and that is why we have a consensus mechanism. In case of Bitcoin, we have proof of work. We have other consensus algorithms as well, like proof of stake, delegate proof of stake. We'll not talk about them. We'll not talk about all of them, but we'll talk about proof of work, or how mining is working over in with reference to Bitcoin. So what happens in consensus algorithm, consensus mechanism, is it is a fault tolerant mechanism where it is just coming up to an agreement that if I have sent some amount of Bitcoin to another person, then everyone within the network is agreeing to it. Because you will have to, because in real life, if I am sending some amount of money to you, you can visually see it, right? I mean, sorry, it is visual to us. We can see that it's happening, right? So that is what we have to take care of. That is what we are trying to take care of over here. And this is all important task is performed by consensus mechanism, which are just set of rules that are decided on the contributions by various participants of the blockchain. Here we come with the concept of mining. Mining is nothing but it is done by specialized computers. Specialized computers as in ASIC processors, if given an example. Because mining requires large amount of processing power. So the role of miners is to secure the network and to process every transaction in the blockchain. Obviously, that is why we have miners. Miners, how do they achieve? They achieve this by solving computational problems which allows them to chain together blocks of transactions. So what is happening over here is they're solving a computational problem. The computational problem is kind of similar to this. I won't say it is completely like exactly like this, but it is kind of similar to this. Again, you have a function. You have been given a value which starts with certain number of zeros and then it has something over here. Some hash or something. Now you have to find a value such that it matches, which satisfies this condition. It has to start with certain number of zeros. Now here comes into picture, I mean here nonce comes into picture. You remember we did talk about nonce. Where was it? We saw nonce over here. So this is what we need here. We are finding a value which with the help of the function used over here, defined over here, or the puzzle that is made in such a way that you are trying to find a value which starts with certain number of zeros, followed by some information, I mean something over there. It is not like this, but it is something. So that is what you have to find, and it takes a large amount of time because every time you solve or you create a block, it keeps on increasing. Difficulty target. Initially, when it was everything new, I mean to say, like when Bitcoin mining had just started, it was possible for people to do it in their normal computers, in their normal systems. But now it has become too difficult. You need large amount of processing power to mine a block. And that is where you define difficulty target, and that is how you find the nonce. Every time the difficulty keeps on increasing. So now it takes, like, for a proper ASIC processor that is created only for mining, takes around 10 minutes to mine a block. In some cases, like the other cryptocurrencies, some of them take 5 minutes, some take 7 minutes, depends upon the number of transactions maybe, or how many transactions that have happened before, because Bitcoin is very much widely used. So it is, the difficulty target is quite high and it takes some time. And as soon as you find the nonce, as soon as you solve the puzzle, you mine the block. I mean, yeah, you mine the block. And in that puzzle, I won't get into more detail about it, but in that puzzle, now the question arises, why some random puzzle? That puzzle is not just a random puzzle. It is having some interesting information, some interesting things that are being used over there. it is using the hashes as well that we have used in that puzzle. And how is it linked, that even we need to get into more detail about it. I don't think that we should be discussing about that. That would become too much complicated. But it does make use of the Merkle root, the hash that we have, the parent hash that we have, that is also being used over there. And that is how they are linked, because it is not just a random cryptographic puzzle that we are just solving. Because unless a Merkle root hash is used over there, how will you verify? Because it is related to verifying verification and validation of the transaction, right? It is related to creation of the block. So that is how it is linked. And once you mine the block, a block is created. As we were in the third step, miners achieve this by solving a computational problem, allowing them to chain together blocks of transaction. And for this, why are miners doing this? Because they're rewarded with newly created bitcoins and some transaction fees. That is why they're doing it. So they are spending a lot of processing power for mining a block, and as a result, they're getting some reward as well. So they're doing it. A transaction can only be considered secure and complete once it is included in the block. But once it is included in the block, you cannot undo it. That is the beauty, and that is one of the advantage and also disadvantage of the blockchain. We'll talk about these things also later on. What are the disadvantages? So how a blockchain works? So a person A wants to send money to person B. The transaction takes the form of a block code, which each transaction is encrypted, obviously, because these are all pieces of code that are working. Block is broadcast across the entire network. Of course, you need to know everyone. It is anonymous. It is transparent. So whatever is happening within the network, everyone knows about it. So those in the network check for certain parameters. If the network approves the transaction as valid, this approved block is then added to the chain and the money gets transferred. So over here, the step 4, here is what is happening is the mining process where the verification and validation is happening. I just tried to get a very simple picture so that we can understand how blockchain is working over here. Otherwise it would become too complicated. I wanted it to be technical but not way too complicated for us to understand, because it is kind of new concept to a lot of people. So once the transaction is verified, validated, it gets updated in the block, and once mining happens, a block is created. Everything is linked, and this is how everything is happening. It is all related to your cryptography and hashes and mathematical puzzle. It is kind of complicated, yes, the piece of code, but the things are not that complicated as well. Like this is the basic things that is happening over here. Mining, how mining works, we did talk about it, right? So the miners solve cryptographic puzzles to mine a block in order to add to the blockchain. Again, this process requires immense amount of energy and computational usage. So you cannot do it in your local system or on your mobile. There are cloud people perform mining using cloud as well, but and cloud mining, but that is kind of slow because again it's related to cloud, and it is kind of slow as compared to the ASIC processors that you're using. The puzzles have been designed in such a way which is making it hard. Of course, we have a difficulty target. We have to find nonce. When a miner solves a puzzle, they present their block to the network for verification. And verifying whether the block belongs to the chain is not an extremely simple process, but it's not that complicated also. But that is how. The main thing that I wanted to talk about in this video is what is happening. What is happening during the process of mining. Of course, I won't get into the completely into complete minute details or at the code level, but I wanted to give you an idea so that we can move to some other part, because we are ultimately talking about security. These set of informations are enough to understand the security aspect that we might be talking about later in future. Now, there are few things that I would want you to think about. Like, as I said in my video, is that it is centralized. So with everyone within the network, it's a peer-to-peer network, right? There is a central authority. Some of you who already have an idea about what blockchain is and everything, I would want people, I do not want you people to answer this, but I would definitely want people who are completely new to blockchain, like they just saw the previous video, which was about what blockchain is in layman's terms. Here I spoke about blockchain, but more technical. I'm just going slowly over here. So if it is decentralized, right, so don't you think that the process of mining is kind of centralized over here? Like, I completely want the people who are not aware of what blockchain is, they're just watching my video or they have very less knowledge, so they can answer. You know, since miners are performing, validating, verifying the transaction, what about that? What is happening? Is it against the concept of, you know, the decentralized nature of blockchain? The second thing, what if the miners are malicious? And I would say that these are few things that if you will search on Google, you will definitely find these things. But I would want you to just do some brainstorming. And then if you have any doubt, just let us know. Here are the references that I have used. I like this website a lot, actually. They've explained everything and I've used their statements only for creating my slides so that it becomes kind of easier for you all to understand because it's very clear. Apart from that, thank you so much, and we'll share the rest of the details with you as well by the end of the video. And thanks. Let us know if you have any doubt. And thank you so much.